Hello students, welcome to Top Scholars. Today we are going to learn a very interesting topic, that is spherical mirrors. Introduction, terms, image formation and uses. Let's get introduced to spherical mirrors. What do you mean by spherical mirrors, students? The mirror whose reflecting surface is not flat like that of a plane mirror. It can be thought as the part of a hollow sphere. Such mirror, students, is called as a spherical mirror. Let's understand this with a diagram. If you consider a hollow sphere A and you break apart B of it, this part can be considered as a spherical mirror. Now students, this spherical mirror can be of two types, depending on whether the reflecting surface is on the outside or on the inside of the curved surface. Students, the mirror whose reflecting surface is on the inside of the curved surface is called concave mirror. On the other hand, if the reflecting surface is on the outside of the curved surface, it is called convex mirror. After understanding what is concave mirror and what is a convex mirror, let's try to draw their diagrams and understand some important terms related to spherical mirrors. Now, if you draw the diagram of a spherical mirror, these are the two types of mirrors, and the shading shown over here is the reflection side. Now, if you consider A, the reflecting surface for this is on the inside, and students, this type of mirror is known as concave mirror. On the other hand, in B, the reflecting surface is on the outside, and this type of mirror is known as convex mirror. The first important term that comes into picture is the pole. What do you mean by pole? Pole is nothing but the center of the mirror, which is denoted by capital P. The next term that comes into picture is the center of curvature. What do you mean by center of curvature? It is nothing but the center of sphere of which the mirror forms a part. As easily you can see from the diagram that the center of the sphere is nothing but center of curvature of the spherical mirrors. The third part that comes into picture is the radius of curvature. Students, if I ask you what is the distance between center of curvature to the pole, right, it is the radius of the sphere, and that radius of sphere of which the mirror is a part is called the radius of curvature, denoted by small r. Now, the next term is very important, and that is the principal axis. The line passing through the center of curvature of the mirror and the pole is known as principal axis, and this line is perpendicular to the mirror of the pole. Students, these are some terms related to spherical mirrors. There are some more terms that we are going to discuss, that is principal focus. Now, when we talk about concave mirror, the rays converge after reflection. So students, remember this, that concave mirror is also known as a converging mirror. Remember this, this is very important. The point at which all the rays parallel to the principal axis meet after reflection is called the principal focus of concave mirror. Let's understand this with a simple ray diagram. Now, this is a simple ray diagram of a concave mirror. In this, suppose if we consider parallel light rays to the principal axis, obviously they will be coming from sun. After reflection, students, they will converge, and they converge at a point capital F. So this was about the principal focus for concave mirror. We also have to understand the principal focus for a convex mirror. In convex mirror, the rays parallel to the principal axis diverge after reflection, and thus students, this mirror, that is convex mirror, is also known as diverging mirror. If these reflected rays are extended backwards, they appear to meet at a point. This point at which the reflected rays from the convex mirror meet after they are extended backwards is called the principal focus of convex mirror. Let's understand this with the ray diagram. Suppose this is your convex mirror. Students, what do you mean by capital P? It is pole of the convex mirror. Now consider parallel light rays from the sun. As per the definition, after reflection, they will be diverged, because convex mirror is also known as diverging mirror. So students, can you please tell me, will the light rays really meet in front of the mirror? No, they cannot, but they can meet behind the mirror if we extend them backwards. And they meet at a point capital F, known as the principal focus. Students, can you please tell me, for convex mirror, the principal focus that is formed, is it in front of the mirror or behind the mirror? Right, it is behind the mirror. And for concave, it was in front of the mirror. These are very important points which will help you to understand the ray diagrams further.
To learn more about this topic, download Toppscholars app.